तस्य रूपमधिकम् प्रच्छन्नगुप्तं धनम् विद्याभोगकरी यशः सुखकरी विद्या गुरुणा गुरुः विद्याबन्धुजनो विदेशगमने विद्या परं दैवतम् विद्याराजसु पूज्यते न तु धनम् विद्याविहीनः पशुः विद्या प्रशस्यते लोकैः विद्या सर्वत्र गौरवा विद्यया लभते सर्वम् विद्वान् सर्वत्र पूज्यते ज्ञानेन सदृशं पवित्रमिह विद्यते न हि ज्ञानेन सदृशं पवित्रमिह विद्यते न हि ज्ञानेन सदृशं पवित्रमिह विद्यते
Dr. Namdev Satyappa Madane is a distinguished academician and researcher in the field of chemistry. He holds a master's degree in chemistry and a Bachelor of Science degree complemented by a Ph.D. in Analytical Chemistry, a testament to his profound knowledge and expertise in the discipline. Since 2013, Dr. Madane has been serving as an assistant professor in the Department of Chemistry at Sathaye College, Autonomous, where his dedication to teaching and research has left an indelible mark. His passion for teaching is deeply rooted in his love for education, inspiring countless students to pursue excellence in the field of chemistry. Dr. Madane's research contributions are both significant and impactful, with several research papers published in renowned national and international journals. His exceptional work has earned him recognition as a Ph.D. guide in chemistry under the aegis of the University of Mumbai, where he continues to mentor aspiring scholars. Notably, Dr. Madane completed his doctoral degree within a remarkable span of just 3 years. His research focused on the extraction and separation of metal ions, a critical area of study in analytical chemistry. He successfully developed innovative methods for the extraction and separation of metal ions, which were subsequently applied to real sample analysis. These methods have been lauded for their reliability, speed, and efficiency, offering valuable advancements in the field. Dr. Madane's contributions to academia and research underscore his commitment to fostering knowledge and innovation. His work not only enriches the scientific community but also sets a benchmark for aspiring chemists and researchers. Let's welcome Vidyavachspati, Dr. Namdev Satyappa Madane.
Namaskar, myself Dr. Namdev Madane, Vidyavachspati. I have completed my Ph.D. degree from Shivaji University, Kolhapur under the guidance of Dr. B.S. Mohite sir. Title of my Ph.D. thesis was Extraction Studies of some Lanthanides and Actinides using Sinex and crown ethers. I have developed some extraction methods for some lanthanides and actinide elements. In this analysis, I use liquid or solvent extraction. It is also called as solvent extraction method. Here the main principle of the solvent extraction, it is based on the distribution ratio. The distribution ratio in which the solute distribute itself in certain ratio between the two immiscible solvents, one of which is usually water and the other is an organic solvent like benzene, carbon tetrachloride or chloroform, etc. In certain cases, the solute can be more or less completely transferred into the organic phase, and the technique can be used for the purpose of preparation, purification, enrichment, separation and analysis on all scales of working, ranging from microanalysis to the production processes. The solvent extraction systems, they can be classified on the basis of nature of extracted species and process of extraction. Nowadays, extraction based on process of extraction is widely used. This can be again divided into different types: extraction by chelation or chelate formation, in which the metal ion forms chelate complex with the chelating agent; extraction by ion pair formation, in which neutral uncharged species are formed, which in turn can be extracted into the organic phase, and that can be back extracted by using various stripping agents. There are other methods like extraction by solvation, synergistic extraction, that can also be used. The very simple apparatus were used for this method development: separating panels, digital flame photometer, digital pH meter, thermoscientific visible spectrophotometer. For my extraction studies, I have used Sinex compounds. By using these Sinex compounds and crown ethers, I have developed the method for the extraction and separation of some lanthanides and actinides. Sinex extractants, they are the organophosphorus compounds. Sinex extractants are phosphorus based products that can be acting different ways. Some of them can be acting as chelating extractants and some of them can be acting as solvating extractants. The chelating extractants are like Sinex 272, Sinex 301. Solvating extractants are Sinex 921, Sinex 923, Sinex 471X, etc. By using these Sinex compounds, the extraction metal can be takes place by ion pair extraction. In the present days, large number of Sinex compounds are used because of their selective extraction properties. In the presence of various counter anions, the extraction properties of Sinex compounds, they are varying largely, and because of this variability, different metal ions can be extracted. The analytical method for the extraction and separation by liquid extraction for uranium-6, that was developed by using Sinex 272 in toluene from sodium salicylate medium. This paper is also published in the journal, that is Journal of Radioanalytical and Nuclear Chemistry. The importance of uranium has grown many folds due to increasing applications of atomic energy. Therefore, there is an analytical requirement for the separation and determination of trace uranium in various types of samples, ranging from geological to industrial scale. Various types of organophosphorus compounds and amides were used to carry out the separation of uranium. Sinex 272 is a novel extractant and we have used for the extraction and separation of uranium-6. We have used the general procedure for the extraction of uranium-6. We have taken 50 microgram of the uranium-6 in a total volume of 10 ml of containing sodium salicylate in the range of 1 into 10 raised to minus 1 to 1 into 10 raised to minus 6 molar. Then this was equilibrated with 10 ml of 5 into 10 raised to minus 4 molar Sinex 272. Then it was checked for 5 minutes and equilibrated. Uranium-6 from the aqueous phase, that was extracted in the organic phase. Then the extracted uranium-6 was back extracted by using various stripping agents like HCl, HNO3, H2SO4, HClO4, HBr, etc. Then this backstripped uranium-6 was determined spectrophotometrically and concentration of uranium-6 was calculated from the calibration graph. For the development of this method, we have varied the concentration of sodium salicylate. We have taken the concentration of Sinex 272 5 into 10 raised to minus 4 molar, and sodium salicylate concentration was varied from 10 raised to minus 1 to 10 raised to minus 8 molar. It was found that there is optimum concentration range is 1.1 into 10 raised to minus 1 molar to 1 into 10 raised to minus 6 molar, there was quantitative extraction of the uranium 6 takes place. Then we have varied the concentration of the Sinex 272. It was found that the optimum concentration range for quantitative extraction of uranium 6 was 1 into 10 raised to minus 3 molar to 5 into 10 raised to minus 5 molar Sinex 272 was. Then we have checked the equilibration time. It was found that 5 minutes of equilibration time was sufficient for quantitative extraction of the uranium 6. Then this extracted uranium 6 that was backstripped by using various stripping agents like HCl, HNO3, H2SO4, HBr, HClO4, acetic acid, etc. It was found that there was quantitative extraction by using these various stripping agents was 0.5 to 6 molar HCl, 0.1 to 8 molar H2SO4, 0.5 to 8 molar HClO4, 1 to 8 molar HNO3, 0.5 to 7 molar HBr, 3 to 8 molar CS acetic acid. It was found that in this concentration range of the trippants, there was quantitative extraction of the uranium 6 takes place. Then we have varied the concentration of uranium 6. We have kept the concentration of Sinex 272 5 into 10 raised to minus 4 molar, sodium salicylate concentration 1 into 10 raised to minus 3 molar, and strippant concentration 1 molar HCl. Then we varied the concentration of the uranium 6 from 50 microgram to 1000 microgram. Then it was found that by this developed method, there was quantitative extraction of the uranium 6 takes place up to 500 microgram. Then we have checked the influence of various diluents on the extraction of the uranium 6. For that we have used various solvents like carbon tetrachloride, chloroform, dichloroethane, n-dodecane, nitrobenzene, tetrachloroethane, toluene, xylene. It was found that carbon tetrachloride, chloroform, dichloroethane, toluene, xylene, with this solvent there was quantitative extraction of the uranium 6 takes place by this method. But for our further study, we have selected toluene as the solvent. Then this developed method was applied for the extraction and separation of the uranium 6 from various binary mixtures, and the tolerance limit was also checked. It was found that there was quantitative extraction of the uranium 6 takes place in presence of various large number of the binary ions. The separation of the uranium 6 from multi-component mixtures were also carried out by using this developed method, and it was found that quantitative extraction of the uranium 6 takes place by using this developed method. Then this developed method we have applied for the analysis of uranium 6 from the real samples like monazite sand and cyanide rock sample. It was found that uranium 6 was quantitatively extracted by using this method. A simple method has been developed for the extraction, separation and determination of uranium 6 using Sinex 272 from sodium salicylate medium. This method permits the separation of uranium 6 from other elements such as thorium 4, beryllium 2, lead 2, nickel 2, copper 2, manganese 2, magnesium 2, molybdenum 6, barium 2, strontium 2. The method was extended for the analysis of uranium in monazite sand and cyanide rock. The method is simple, rapid and selective with good reproducibility, approximately plus or minus 2%. Then we have developed the reliable analytical method for the extraction and separation of the thorium 4 by using Sinex 272 in kerosene. This paper is also published in the Journal of Radioanalytical and Nuclear Chemistry. Now we see that the world is facing increasing need of energy day by day. Therefore, to fulfill these demands, nuclear power plants are largely establishing, and thorium is used as a source of fuel for atomic energy programs, and its uses in refractory materials, magnesium alloys, gas metals, polishing chemicals and medical products, photoelectric cells. Therefore, there is an analytical importance for the separation and determination of the trace thorium in various types of samples ranging from geological to nuclear waste materials. Solvent extraction is the most widely used and versatile technique for the separation and recovery of the thorium. The analytical method for the extraction and separation of thorium 4 that was developed by using Sinex 270 in kerosene. For this, we have checked various parameters. Then we have varied the concentration of sodium salicylate. It was varied from 10 raised to minus 1 molar to 10 raised to minus 8 molar. And it was found that the optimum concentration range for quantitative extraction of thorium 4 was 1 into 10 raised to minus 4 to 1 into 10 raised to minus 7 molar. Then we have varied the concentration of Sinex 272 from 10 raised to minus 1 to 10 raised to minus 5 molar. And the optimum concentration of Sinex 272, it was found that 1 into 10 raised to minus 3 molar to 5 into 10 raised to minus 5 molar, there was quantitative extraction of the thorium 4 takes place. Then the extracted thorium 4 from the organic phase, it was backstripped by using the various stripping agents. For that purpose, the strippants like HCl, H2SO4, HBr, HNO3, HClO4, acetic acid, they were used and their concentrations were varied from 0.5 to 8 molar. It was found that quantitative extraction of thorium 4 takes place by 0.5 to 6 molar HCl, 0.1 to 8 molar H2SO4, 0.5 to 8 molar HBr, 2 to 8 molar HNO3, 1 to 8 molar HClO4, 5 to 8 molar acetic acid. Then we have checked the effect of diluents on the extraction of thorium 4. For that we have used various solvents like carbon tetrachloride, chloroform, dichloroethane, N-dodecane, nitrobenzene, tetrachloroethane, toluene, xylene, kerosene. It was found that there was quantitative extraction by using toluene, xylene and kerosene where takes place. Therefore, for further extraction studies of thorium 4, I have used kerosene as a solvent. It is acting as a green solvent. Then we have studied the effect of various Sinex extracted on quantitative extraction of the thorium 4 by using sodium salicylate medium. So we have used Sinex 272, Sinex 301, Sinex 923, Sinex 471X. It was found that by this developed method, using sodium salicylate Sinex 270, there was quantitative extraction of the thorium 4 takes place. And therefore, for further studies, we have used Sinex 272 as an extractant. Then we have varied the concentration of thorium 4 by this developed method. Concentration of thorium 4 was varied from 50 microgram to 500 microgram, and it was found that by this developed method up to 450 microgram of the thorium 4 it was takes place quantitatively. Then we have studied the influence of various binary ions on the extraction of the thorium 4 and tolerance limit that was also checked. It was found that thorium 4 was quantitatively extracted by using this method in presence of various foreign ions. Then the separation of thorium 4 from multi-component mixture was also carried out by using this developed method, and it was found that quantitative extraction of the thorium 4 can take place in presence of large number of the multi-component mixtures. Then the developed method we have applied for the analysis of thorium 4 in real samples like gas mantle, monazite sand. It was found that by using this method, there was quantitative extraction of thorium 4 takes place, and quantitatively we have determined the thorium 4 from these real samples. A simple method has been developed for the extraction, separation and determination of thorium 4 using Sinex 272 from sodium salicylate medium. The method permits the separation of thorium 4 from other associated elements such as uranium 6, strontium 2, rubidium 1, cesium 1, potassium 1, sodium 1, lithium 1, lead 2, barium 2, beryllium 2, which are usually associated with nuclear fission products. The method was extended for the analysis of uranium in monazite sand and gas mantle. The method developed is simple, rapid and selective with good reproducibility, approximately plus or minus 2%. Then we have developed the analytical method for the separation and extraction of the cerium 3 using Sinex 923 in kerosene from sodium acetate medium. This paper is also published in the journal Research Journal of Chemistry and Environment. Among rare earth elements, cerium is the most abundant and it is about 0.0046% of the Earth's crust. Cerium is found in a number of minerals including allanite, also known as orthite, monazite, bastnasite, hydroxyl bastnasite, zircon, chinchosite. Monazite and bastnasite are two important sources of cerium. Commercial applications of cerium are numerous, including magnetic catalysis, polishing powder, and ceramic technology. Then, for the development of extraction of cerium 3, we have varied the concentration of sodium acetate from 0.1 molar to 1.6 molar, and it was found that quantitative extraction of cerium 3 takes place by using Sinex 923 in the concentration range of 0.3 to 1.5 molar. Then we have varied the concentration of Sinex 923 from 0.1 molar to 1 into 10 raised to minus 1 molar, and it was found that quantitative extraction of the cerium 3 takes place from 7 into 10 raised to minus 3 molar to 4 into 10 raised to minus 3 molar. Then various stripping agents that were used to backstrip the extracted cerium 3. For that purpose, HCl, HNO3, H2SO4, HClO4, acetic acid, HBr, these stripping agents were used in various concentration range, and it was found that the quantitative extraction of cerium 3 takes place from 3 to 8 molar HCl, 1 to 8 molar HClO4, 4 molar HNO3, 3 to 8 molar HBr. Then the influence of various diluents on the extraction of cerium 3 that was studied. For that purpose, various solvents were used like carbon tetrachloride, chloroform, dichloroethane, N-dodecane, nitrobenzene, tetrachloroethane, toluene, xylene, kerosene. But it was found that with kerosene as a solvent, there was quantitative extraction takes place by this method, and for further studies, we have used kerosene as a solvent. Then we have varied the concentration of the cerium 3 from 50 microgram to 450 microgram, and it was found that there was quantitative extraction of the cerium 3 takes place up to 300 microgram. Then this developed method, it was applied for the extraction and separation of cerium 3 from various binary mixture, and the tolerance limit for various metals were also checked. It was found that quantitative extraction of the cerium 3 takes place in presence of large number of the foreign ions. Then extraction and separation of the cerium 3 from large number of multi-component mixtures, that was also carried out quantitatively. Then the developed method we have applied for the analysis of cerium 3 in geological samples. For that purpose, we have analyzed the cerium 3 from the real sample like the monazite sand. Monazite sand, about 1 gram of the monazite sand was dissolved in a mixture of nitric acid and sulfuric acid in 1:1 proportion. After separating the insoluble silica, the solution was diluted to 100 ml with distilled deionized water. An electrode of sample solution was subjected to the further by developed method, and extraction of cerium 3 takes place quantitatively. A simple method has been developed for the extraction, separation and determination of cerium 3 using Sinex 923 in kerosene. The method permits separation of cerium 3 from other associated elements such as uranium 6, iron 3, lithium 1, potassium 1, cesium 1, molybdenum 6. The method was extended for the analysis of cerium in geological samples such as monazite sand. The method is simple, rapid and selective with good reproducibility, approximately plus or minus 2% error. Then I use crown ethers as an extractant for the separation of some of the lanthanides and actinides. Crown ether is a generic name given to macrocyclic polyethers containing ethylene bridges separating electronegative oxygen atoms. The discovery of macrocyclic polyethers is interesting in recent developments of separation chemistry. They typically contain central electron-rich hydrophilic cavity with diameter varying from 1.2 to 6 angstrom. The hydrophilic cavity is ringed with electronegative binding heteroatoms such as oxygen, nitrogen, sulfur, etc., which in turn are surrounded by a collar of CH2 groups, forming a framework which is flexible and exhibit hydrophobic behavior. The hydrophobic exterior allows them to solubilize the substances into non-aqueous solutions and in membrane media. Such properties facilitate for their use as extractants and separation of the metal ions. C.J. Pedersen, he has first synthesized crown ethers and was awarded the Nobel Prize in Chemistry in 1987 without having a Ph.D. So he is called as father of crown ethers. He has synthesized various crown ethers: 12 crown 4, 15 crown 5, 18 crown 6, diaza 18 crown 6, dibenzo 18 crown 6. For my further study, I have used dibenzo 18 crown 6 as an extractant. By using crown ethers as an extractant, we have to take into considerations the various factors influencing on the extraction studies. They are distribution of ligands in the aqueous phase, size of the cations, charge on the cation, nature of donor atoms, nature of diluents, nature of counter anions. Then I have developed an analytical method for extraction and separation of thorium-4 by using dibenzo 18 crown 6 in xylene. Thorium has been widely used in various applications, so thorium has great importance. Thorium is a component of magnesium alloys series called as MagThor, used in aircraft engines and rockets and imparting high strength and creep resistance at elevated temperatures. Thoriated magnesium was used to build the CIM-10 bomb missile. Although concerns about radioactivity have resulted in several missiles being removed from public display, thorium is used as a source of fuel for atomic energy program. Our India is having large coastal area, and in that monazite sand is richest source of thorium, and therefore there is need for the extraction and separation of the thorium takes place. In this method, we have varied the concentration of L-histidine on extraction of the thorium-4. So we have varied the concentration of L-histidine from 0.1 molar to 10 raised to minus 5 molar, and it was found that optimum concentration range of L-histidine was from 1 into 10 raised to minus 2 molar to 3 into 10 raised to minus 4 molar. There was quantitative extraction of the thorium-4 takes place. Then we have varied the concentration of dibenzo 18 crown 6 and studied what is the effect of concentration of dibenzo 18 crown 6 on the extraction of thorium-4. It was found that there was quantitative extraction of thorium-4 takes place in the range of 1 into 10 raised to minus 3 to 1 into 10 raised to minus 4 molar dibenzo 18 crown 6. Then we have studied various tripping agents like HCl, HNO3, H2SO4, HClO4, HBr, acetic acid. Then it was found that there was quantitative extraction of thorium-4 takes place by using the stripping agents in the concentration range from 0.5 to 8 molar HNO3, 0.1 to 8 molar HClO4, 1 to 6 molar H2SO4, 4 to 7 molar HBr. There was quantitative extraction of the thorium-4 takes place. Then we have varied the various solvents and found what is the effect of these diluents on the extraction of thorium-4. It was found that there was quantitative extraction of thorium-4 takes place by toluene, xylene and kerosene. Then we have studied the effect of various concentration of the thorium-4 on the extraction by this developed method. So we have varied the concentration of thorium-4 from 50 microgram to 220 microgram, and it was found that there was quantitative extraction of thorium-4 takes place up to 100 microgram by this developed method. Then we have studied the influence of various foreign ions on the extraction of thorium-4 by this developed method, and also the tolerance limit for this was checked. It was found that there was quantitative extraction of thorium-4 takes place by using the developed method in presence of large number of foreign ions. Then we have studied the separation of thorium-4 from binary mixtures, and it was found that in presence of large number of binary mixtures, thorium-4 was quantitatively extracted by this developed method. Then we have applied this developed method for the analysis of thorium-4 from real samples like gas mantle, monazite sand. It was found that quantitative extraction of thorium-4 takes place by using this method from the real samples like gas mantle and monazite sand. A simple method has been developed for the extraction, separation and determination of thorium-4 using dibenzo 18 crown 6 in xylene. This method permits the separation of thorium-4 from other associated elements such as barium-2, strontium-2, beryllium-2, lithium-1, sodium-1, potassium-1, cesium-1, rubidium-1, cobalt-2, nickel-2, cadmium-2 and zinc-2. The method was extended for the analysis of thorium-4 in gas mantle and monazite sand. The method is simple, rapid, selective with good reproducibility, approximately plus or minus 2% error. I want to thank you the management of PTVA for giving me this opportunity as a Vidyavachspati to present my research work. I also thanks to my guide Professor Dr. B.S. Mohite sir, who has guided me and have helped me. Thank you.
ज्ञानेन सदृशं पवित्रमिह विद्यते नहि ज्ञानेन सदृशं पवित्रमिह विद्यते नहि ज्ञानेन सदृशं पवित्रमिह विद्यते